Good morning, all too. My name is Sekhar Reddy, Senior Physics Faculty. Welcome to GPS's Physics classes. So today we are going to discuss about motion of a body on a rough horizontal surface. So previous we were discussed about types of frictional force, normal force, and normal force in different cases. Now we are motion of the body on a rough horizontal surface. So now consider a rough horizontal surface like this is rough horizontal surface. A block of mass M rest on the surface. So initially consider the rough horizontal surface. A block of mass M rest on the surface. So already we know that the frictional force tangentially opposite direction to the two contact surface. The weight of the body acts vertically downward direction at the same time. Normal force 90 degrees to the surface. Normal force 90 degrees to the surface. Like normal force. So like this is center of the block. So if you are applied, like this is applied force. Applied force. Applied force forward direction. Frictional force tangentially opposite direction to the two contact surfaces. The weight of the body acts on the surface, downward direction. Normal force vertically upward direction. Along vertical direction, there is no motion. That means net force 0 is equal to N positive direction, mg downward direction. That means normal force is equal to weight of the block. So here applied force here, frictional force opposite direction. Now, if applied, is equal to 0, 0, then Fs is also 0. Static frictional force. Body rest condition means static frictional force. If F applied increases, then Fs is also increase. So starting F applied 0, starting frictional force 0, F applied increases, Fs is also increases. Now in first case, like F applied is less than static frictional force. The body does not move on the surface. Okay, so body rests on the surface, applied force 0, Fs 0. Applied force increases, Fs is also increases. So if F applied less than static frictional force, body does not move on the surface. F applied is equal to Fs. Fs max mean that is equal to limiting friction. The body ready to move on surface only ready to move. Okay, so F applied equal to static frictional force. That means static friction maximum that equal to Fl, limiting friction. Where limiting friction, the body ready to move on the surface. Now F applied greater than limiting frictional force. Body moves with resultant force. Resultant force F1. Resultant force F1. So here F1 move F1 along the application of upright force, limiting frictional force, opposite direction. Here F applied greater than to limiting friction. That frictional force converted to kinetic friction. So in this condition, F applied greater than to limiting friction, that frictional force converted to kinetic friction. Therefore, Fr is equal to F applied minus kinetic friction. But Fr is equal from Newton's second law of motion, mass into acceleration. F applied minus kinetic frictional force. That means acceleration of the body on a horizontal surface. F applied minus Fk by m. F applied minus Fk by m. Okay. After crossing the upright force, limiting friction, that is converted to kinetic friction. So that is resultant force is equal to F applied minus kinetic frictional force, but Fr is equal to Ma is equal to F applied minus Fk. A is equal to F applied minus Fk by m. This is acceleration of the body on rough horizontal surface. So this formula, this is the acceleration of the body on rough horizontal surface. Horizontal surface. Rough horizontal surface. Now, if the body moves with uniform velocity, so that is acceleration A is equal to 0. That is acceleration A is equal to 0. Uniform velocity means there is no change in velocity. That means acceleration becomes to 0. So therefore, this equation becomes to 0 is equal to F applied minus Fk by m. So I am transfer here 0 into something 0. That means F applied minus Fk is equal to 0. F applied is equal to Fk. F applied is equal to Fk. So Fa is equal to, we have to write Ma. Fk is equal to, we know that mu Kn. Fk is equal to mu Kn. Ma is equal to mu k, where what is the n value? Mass of the block into acceleration due to gravity. mg, get cancelled. A is equal mu k theta. So this equation indicates the relation between coefficient of friction and acceleration. This is indicate coefficient of friction and acceleration, or simply we have to represent it. A is equal to mu c. A is equal to mu c. So this is very most important for solving the problems. Solving the problems. So next the minimum force. The minimum force required to move the body on rough horizontal surface. Horizontal surface. So is equal to how much? FL is equal mu s mv. FL is equal to mu s mv. So if the body rests on the surface, the body ready to move purpose, minimum force applied, that equal to lifting force. Limiting frictional force. FL is equal actually mu s n. FL is equal to mu s n. N is equal to mg. Since FL is equal to mu s n. FL is equal to mu s n. Okay, so here how many formulas is there? One is you find the acceleration of the body on rough horizontal surface. A is equal to F applied minus kinetic friction by mass of the body. Next one, if the body moves with uniform velocity on the rough horizontal surface, F of result force becomes 2. That acceleration 0. 0 is equal to F minus Fk by m. So here F minus Fk is equal to 0. Fa is equal to Fk. But Fa is equal to, we have to write mass into acceleration. Fk is equal to Vkn. So that means Ma is equal to Vk. N is equal to how much? Mg. A is equal to mu kg. This is relation between coefficient of friction and acceleration due to gravity. So in this equation, A is equal to mu kg. Generally, we have to represent it. The relation between A and mu. A is equal to mu c. A is equal to mu c. So next point. The applied force continues on the body with body under the motion. Under the motion. Okay. So before moving purpose, applied force equal to limiting frictional force. So if cross the limiting frictional force, body continuously moves with a certain acceleration. So now body already under the motion, the applied force continuously. That means we have to write Fr is equal limiting frictional force. That result is equal to limiting frictional force minus kinetic frictional force. Here Fn is greater than to Fk. So Fr we have to write Ma. Fk is equal, Fl is equal mu s n This is equal to mu k n. So n will common mu s minus mu k. Ma is equal, n is equal to how much? Mg, mu s minus mu k. So mm get cancelled. A is equal to g of mu s minus mu k. Okay, this relation indicates acceleration due to ground acceleration of the body on a horizontal surface and the coefficient of kinetic static friction and the coefficient of kinetic friction and the acceleration due to ground. So this is also one relation you should remember. Okay, finally conclusion formulas you should remember. So formulas you should remember are key points. Key points. First formula we know that A is equal to F applied minus Fk by M. Next formula. A is equal to mu k g. Second one, or simply A is equal to mu z. So next to third formula, minimum force Fn is equal to mu s mg. Okay, minimum force required, the body ready to move, how much applied is equal to limiting frictional force. Next to fourth one, A is equal to g of Vs minus Vk into Vk. Okay, so these four formulas will use to solve the mains or NEAT or MSET problems. So this is the acceleration of the body on horizontal surface. So this is a relation between K and mu. So this is minimum force required. Fl is equal to Vs and G. Fl means limiting friction. That means maximum static friction. Next is the relation between Vs, Vk and A is equal to G of Vs minus Vk. Okay, these are very most important formulas. Okay, thank you for watching. Please share, like, and subscribe, support to me.